We know in future, what is indicative of a failure about to happen, and we can look out for it. But really, it comes when you've had that first success, you've caught that first breakdown, you've seen the first instances of a case being raised in Senseye before the system has failed, and then you realise, this is not just a condition monitoring tool. It sees really deeply into the behaviours of your machines, and Senseye is really powerful in that sense.
Welcome to the Trend Detection Podcast, powered by Siemens, and now your host, Niall Sullivan.
Hello and welcome to the latest episode of the Trend Detection Podcast. I'm really pleased to be joined once again by my colleague Tom. He's been on the podcast many a time. The last time was actually in the studio, but we're remote this time. But really pleased to have you back, Tom.
Brilliant. Hi, Niall. Good afternoon.
Good afternoon. And so today we're going to be talking about predictive maintenance in practice. And I guess what I mean by that is sort of in the real world. And I know, all the episodes we've done together and, lots of other guests as well, providing their own perspective. And you've got a fantastic one, of course. But yeah, we're going to go into the detail each step of the process. And the process, of course, starts with a project kickoff. So if we start there, Tom, so what actually happens or usually happens in the first sort of 30 to 60 days? And is there sort of a difference between what we do and what the customer thinks might happen in that period?
I think sometimes there is. So I'll gladly go into it. I mean, for anyone who's not listened to me on the podcast before, my name's Tom, Solutions Engineering for Senseye, covering really that first part of a project. So what we call scope when we do a predictive maintenance project. And of course, within that, you have to understand, first of all, what kind of project are you looking for? Is this a downtime avoidance project? Are you perhaps over-maintaining the system? And that's something you need to look to mitigate. You're spending lots on spare parts, or you're doing lots of time-based maintenance, perhaps quite often unnecessarily. But equally, you could be GXP compliant and you need to do certain regulatory changes and repairs and so on to keep things operational. Things like food and beverage, you'll need to keep things clean. So there's cleaning windows. Those are often also very good maintenance windows. We often see different customers with different requirements. And I think really when we kick a project off, the first thing we need to do is just get alignment, make sure we all understand what the objective is going to be for the project, make sure we're capturing data, make sure we've got the right sensors and things in place. And really just, look at the sensors and the assets and the kind of hardware that we've got available to us. If we've got, motors and pumps and gearboxes or whatever the assets are that we're looking at. Again, Senseye is covering rotating, non-rotating assets. I think the first thing is really look at what assets we need, look at where the downtime is most impactful or where the problems lie, and figure out how we're going to get that data through to the Senseye platform, which is all cloud-based, and then how are we going to see success? So make sure that we're set up in the right way for practical delivery of the project, and also just understand if there's a historian in place already, the data capture is already there. Also what the workflow looks like. Is there already a CMMS solution in place? Do we plan to integrate those two things? And really, how is it going to impact the maintenance team? So Senseye is inherently a maintenance product, and that is really the team that's going to impact the most. It will change the way operations are currently run. And to be honest, Noel, we've seen customers where it even might be a paper-based process still. Wow. We just want to make sure that the process from whatever is currently there to Senseye is also mapped out and the expectations are sort of laid out correctly.
And in those sort of various different sort of phases and parts of the process, is there a place where projects commonly stall or slow down in particular? Is there something that sort of holds things up?
Yeah, I think making sure you've got the right resource and also making sure everybody on the Siemens side, also when there's partners involved, the partner side, right the way through to the end customer, that the resource is there. Now, that could be financial, it could be skill sets, it could be time. Sometimes, especially in maintenance teams, you're pressed for time. You've got lots of things to fix and keep running. Starting a pilot with a predictive maintenance product sometimes isn't the top priority. We see that quite often. And it's making sure that the resources are in place before that then slows you down at a later stage. Really, as well, from my perspective in solutions engineering, is that we we scope the project properly so that we make sure that whatever it is that you're looking to solve, we're going to be able to do that and we're not missing anything. So if we're going to monitor a certain drive, we know that drive can output the values that we need, for example. All of these things need to be thought about. And the better job we do of a scope phase, of understanding the assets and really working together with the customer to make sure we get the project right, the better the project tends to run. You could easily halve the length of a project or shave many weeks off a project just by doing the scope phase correctly.
I was wondering, because when you say the right resources, I imagine that across a lot of projects, it would be, similar roles or similar departments. But then in others, it might be different, whether it's due to culture or the size of organisation. And it also just reminded me of our colleague, Natalie, who was on the podcast, or we recorded a podcast last week. And she said that actually joining the case review calls was the CEO of this particular company, right? Which is, I still can't believe that they're so involved in it. I mean, that's quite rare, but does it vary between different companies, what resources are required, or is it quite sort of standardised, certain roles? Which
it can vary. I mean, that example from Natalie is a very good one because it's about stakeholder management. So perhaps from the bottom level, there's a team that want to push this, but in some cases, management don't understand it. They don't see where this is going to benefit the business. So stakeholder management is really important. Make sure the sponsors who might pay for the project, they understand the benefits. How is this going to pay for itself? What is the objective of the project? Also, we call them pilots, but we're not testing that the product works. We know Senseye is a very powerful tool. We know that it can do what it says on the tin, for want of a better phrase. But really, it's making sure that messaging is passed across to the people that will be involved. And again, that's part of speeding up the project. If you explain all that stuff in the first instance and you get buy-in from the right people, yeah, absolutely.
I guess amongst those different roles as well, I mean, how does that transition between, the initial sort of excitement of getting the project up and running and looking at assets and all that kind of thing to actually handing over to sort of the operational side? So we've set everything up now, off you go. It's time to use this day to day. And I know it's not just a seamless handover and that's it. Obviously, there's continuing support. But yeah, how does that work from a customer perspective?
Good question. I think when customers have expectations in the first instance, the goal will, of course, be we need a tool that's going to help us with the maintenance. We need at the minute, we're very reactive. We find ourselves chasing our tail quite a lot, especially when you then need spare parts that you might not have in stock or for whatever reason, there's other delays throughout any maintenance process. And to be able to anticipate what's going to happen is really important. I would say, just being able to determine there's anomalous behavior or trending behavior, moving away from a baseline, increases in vibration, increases in temperature, and so on. Again, just as one reference point on a motor, that's a very typical rotating asset. A large part of industry is kind of built on motors, three-phase motors, and so forth. But really that the expectation is there. So if you say we want to capture failures, okay, but how? So what data have we got available? Do we need to make some data available? Is a methodology here where we can implement IoT sensors to extract, additional insight, vibration sensors there being a really, really useful one. New features and functionalities of Senseye where you can look at the spectra in Senseye and get it to really do the analytics for you in the tool rather than having to get a manual report done on 100 motors that you've got in place. And then look to the future and you say, well, okay, if we implement it on these assets, we've got 10 of those, but actually if we implemented it on these conveyors, for example, we've got 1,000 of those, perhaps in a logistics facility or other customers where you might see big mining operations. Senseye is really scalable, so the tool can learn and that data can be shared across fleets and groups of assets. I think really when the project starts, looking at how you foresee it moving forward, basically, and there's always the outlay of, well, these assets would be better, but we're going to have to pull lots of extra data. We're going to have to really do a hardware install project, to pepper this thing with sensors. But actually over here, we've got loads of data in the drives already that Senseye can leverage. We just need to make sure we can capture that data, pull it from a historian, and really then just leverage that. Start basically where the low-hanging fruit is, and make sure that the team are, fully on board with that.
That's an interesting point about sort of looking to the future. But what I think inspires that is these sort of aha moments, where I'm not saying people, or maybe you do have some people who are skeptical to start with, but even people who aren't skeptical, they're waiting for that moment where like, oh my word, that's amazing. It's completely this is going to change everything. I need to apply this to every asset or as many assets as we can. But what triggers those moments from your perspective, Tom, from your experience?
Usually that comes when you've started a project and you start to see success somewhere, or you think if we just modify the parameters on this slightly, we've just seen a bearing failure, or we've just seen a system breakdown because of poor oil quality or something like that in a loop system. As soon as you can start to capture that data, and maybe you've just missed the failure, but then of course the work that we do together, you modify those settings, decrease sensitivities of certain measures and so on. That allows us to really ensure that we can effectively stand a much better chance of capturing that failure in the future. And then once we know what that failure looks like, we can match against that. So we know in future, what is indicative of a failure about to happen, and we can look out for it. But really it comes when you've had that first success, you've caught that first breakdown, or you've seen the first instances of a case being raised in Senseye before the system has failed. And then you realize, this is not just a condition monitoring tool. It doesn't just alert you to a violated threshold on a measurement of temperature, for example. Senseye is really powerful in that sense, to have the intelligence to see. I really want to get sort of philosophical about it, but it sees really deeply into the behaviors of your machines. And then with Copilot, you can start to ask questions to the motors and pumps themselves. It sounds crazy, but really that is as good as I can explain it. It's the same as being able to then speak to the asset and ask it, what happened, how did that happen? Why did that happen? And it will then give you all those recommended actions based on, we saw this was indicative of this type of failure on this asset. If it's, let's say, a loop system, you can see that it's based on a high ISO code in the oil quality, really degrading. So you can see that ISO code's increased. That's then indicative of, you need better filtration. You need to find ways of mitigating that in future, so it doesn't happen again. And then it learns from all that stuff that you do. So every time you've fixed a problem, you fill into the tool what you've done to fix it. That's then used as suggestive action in the future, and pulling data from PDF documents and so on. So it can troubleshoot the system for you as well. But yeah, I think when it really comes down to some of the challenges, I think one of the things we have to make sure is that we're not over-egging the pudding. We really have to make sure that we set the expectations correctly. If it's a small data set, or you maybe make 100 different products on the same production line, that's going to take longer to understand normal operation for each of those different batches or products. And it's essential there that we set expectations correctly, depending on what we're looking at.
It's funny, Tom, when you were saying about talking to motors, imagine like they're like your best friends, right? So I don't know why that appeared in my head, when you're using the Copilot to understand them a lot more. But
it's almost like it reaches out to you and says, I've had a misalignment. I really need you to come and support me. That is effectively what it's doing.
No, but I completely get it. I guess what I wanted to sort of add on to that point is also, you talked about Senseye and we talked about aha moments, but of course, for an insight to be really useful is someone to actually act on it, right?
Yeah.
And so what usually determines whether maintenance teams act on something? What gives them the urge to do it? We've got lots of examples where Senseye has spotted things and then people have shrugged their shoulders, something's broken down, and then it's, what happened here? Those kinds of scenarios.
Fundamentally, it comes down to trust. If someone who's very knowledgeable says, I can hear that machine's clunking and making strange sounds, I think that is about to fail. And, that is indicative of a bearing that's about to collapse. It's only subtle hints, but that's for decades, a very tried and tested method. If it starts to sound different, or you see very simple sensors that tell you it's getting hot, as soon as you see a bearing that starts to get hot, you can see there's increases in friction. That bearing's not doing what it should be doing. What we try and do is look out for culmination of different things. You can compile that. You can have correlations between measures and so on, control parameters and so on. What the software needs to do once it's all been set up is prove to the customer that it can actually do what we say it can. If it's going to indicate to you that there's a failure, that really is true. Of course, when you close a case, it gives you the option to say, this was very helpful, excellent, very, very useful. Equally, no use at all. Maybe there's a process change that's caused strange behaviors, or wildly high ambient temperatures has indicated that the bearing is hot, but actually it's just a very, very hot day. So making sure we've got other measures in there to pick that stuff up. We've factored in maybe a delta between two temperatures so that we know it's just the difference, making sure that the system is set up correctly so that we capture. And of course, we do this on many thousands of assets, so we know what we're talking about. But making sure we can build the trust, because if you have a team of people who don't believe it, the alert will pop up exactly as a condition monitoring software did 10 years ago to say, oh, I think this is a failure. You need to go and have a look at it. Or you get nuisance alerts where it just keeps bouncing off a limiter to tell you need to go and have a look at something. Sometimes previous bad experiences with old software in the quote unquote predictive maintenance space has built that negative image of what the software is capable of. That's probably one of the biggest hurdles we have to overcome at Senseye, because Senseye is, as far as I see it, the only tool that can really, really do this with enormous amounts of analytics in the background. Yeah, it's just about building trust. It's making sure that when there's an indication that the team then realize, okay, that's Senseye. We know this isn't a false alarm. We know it's based on good data, good historical information. We know that it really has seen something. We need to go and do some checks, do those things, and then you think, wow, brilliant. That's just saved us 10 hours of stoppage in whatever facility, a steel plant or a chocolate making facility, whatever we're looking at.
And that, I call it confusion, the market confusion, let's call it, where predictive maintenance is applied to so many different products and companies and stuff. So no wonder people are so confused. And I guess does that sort of lead sometimes, building of trust is one thing, but where you have customers who move from, say, a proof of value position to using it day-to-day in operations and scaling, and off they go, to the ones who get stuck in this cycle of proof of value. Is there something that sort of separates the two, the mindset, beyond the market inflating expectations, let's say?
I think once it becomes embedded in daily operations, it becomes very easy to trust it. In the first couple of instances, we do see this with sort of fledgling customers. They've got their first 100 asset project, let's say, and then they get an alert. They'll tell the system, yeah, we've been to have a look at it. We don't think there's a problem. And maybe 2 or 3 weeks down the line, you get what I would class as a catastrophic failure, serious damage in a gearbox or something else goes wrong. And the signs of that failing and breaking down were highlighted 2 weeks ago, but you don't realize the sensitivities of it. You don't realize perhaps it's seen something that another software or maybe nothing has ever seen before. You have to learn to work together. And it really is like that, because it becomes like a watchdog that's looking at the system 24/7. I think most people that are listening to this, more than understand that. I'm not going to dumb it down to any stupid levels, but I think really it's important that it alerts to something. Maybe once you get to that stage of having a work order integration, it's raising that. And it's not just raising loads of unnecessary stuff that's just realistically going to annoy you. It's designed to work together. It's like a symbiosis of man and machine working together to capture stuff. Because very often we do this for the maintenance team, but it's the production teams at the end of the day that are ensure that they are looking to the maintenance team to say, we're expected to produce X, Y, and Z, but you guys need to give us the machines, the production lines to make that possible. If we don't have that, realistically, we can't do our job. That's going to annoy senior leadership, also end customers, and contracts that need fulfilling to output certain products. And that means there's huge pressure on maintenance teams to keep everything running, often on a shoestring budget, with limited resource, limited training, limited skill sets. And Senseye really helps to fill in all of those blanks. And that's a huge sales pitch, of course, but we see this at scale. We see how successful it is. If anybody ever wants to speak to me about this, I'd happily have a call with anybody, give a demo of the tool and share how this works. And our teams across the globe can also do the same. So to anybody listening to this in any corner of the world, we can share this with you. We can share successes of how it works and that it's not rubbish, basically, and prove what we're saying.
Absolutely. And, how long does it take for PDM to become sort of business as usual? And again, it's going to depend on size of deployment, customer, industry. But is there sort of a rough sort of rule of thumb you could point to, Tom?
I would say, yeah. I mean, it depends on the assets and the industry, exactly as you just said it. And I'm not going to say how long is a piece of string to be flippant, but I think you need to give the tool a little bit of time to understand the asset, understand what normal behavior looks like. One of the main questions we do get asked quite often, is there a chance that we're actually on board in this motor in a failed state or a failing state already? It's 80% of its remaining useful lifetime is gone, it's really weeks away from failing. So you're going to learn that as normal operation. The answer is we'll learn it as behavior. Then we give, obviously, the engineers the chance to explain what happened, that it broke down, and that what we saw there is already indicative of a failing asset. And it knows that for future reference. And our delivery teams and all the rest of it can make sure that that is built into the tool. In the future, when it happens again, maybe within the next 2 months or 3 months, whatever it might be, it really, really does there depend on what the asset is, how often it's running. So it might be running 24/7, it might be running 6 hours a day. You can imagine there that's going to take 4 times longer, respectively, if it's the same asset, let's say, with all the same variables. But yeah, I think most of our customers will say they start to trust the tool within 6 months, or 6 months to a year, just to be really sure I'm not being too overly optimistic on that one.
We won't hold you to it, Tom.
Yeah, and that's the thing, isn't it? Like, if it's set up correctly, I would always say 6 to 12 months, you're going to see real big benefit, and you'll get analytics done on that asset that have never before been possible.
Awesome. What I didn't warn you about before this, Tom, is we now have a lightning round, so there'll be some questions. just 3 quick fire questions. But before we get to that, I just wanted to ask a couple more questions. And going back to where we started about customers' expectations, what they expect to happen. But what's one sort of assumption customers always have or regularly have that turns out to be wrong? From the early sort of kickoff and scoping meetings, is there something where assumption is proved to be incorrect?
That is a great question. If I was to answer that question really as well as I can, I would say it's not magic. Senseye is not magic. Sometimes it can feel really clever. It can feel a little bit like magic, but you have to really fill it in and give it feedback and help it along the way. You have to do the work mechanically. You have to highlight what you've done to fix problems. It will still find things. So all you're doing there is increasing the chances, improving the intelligence of the tool. Also, when you upload PDF documents and so on, so it's got that extra knowledge and information of how to fix a bearing or a pump or whatever asset we look at. And I would just say, make sure everyone's aligned on it. So it's a cultural thing more than anything. It is a technical thing. We're changing the way we extract data, the way we do the analytics of a motor or whatever. But really there, you need to make sure when Senseye alerts you to something, what's the cultural process that you're going to follow? Is there a proactive approach? Everyone will sit together, and 9 times out of 10, if not 10 out of 10, it changes the culture positively for the customers that use Senseye, because they start to trust it. It starts to help them. It's a tool that, of course, costs money, but it saves you even more. So it's a tool that's designed to really positively change the way you go to work. And I think to be able to sort of proactively look at a tool, react to that thing that's going to tell you of a bearing failure, that's much more fun than reacting to bearing breakdowns that have already happened, lines have already stopped, and so on. So
even me, nowhere near sort of that world or level of expertise, could tell that as well. So much more to spot it ahead of time. And I guess also, so if a customer asked you one piece of advice after the contract is signed, but before the kickoff of the meeting, what would you tell them to focus on first or think about first?
Ooh. What I would say, and what we see often, scope workshops and beyond, is make sure everyone's on the right page. So the teams that are all maybe in separate departments, maybe they already work very closely together, but they will still end up working more closely together. Make sure that there's really alignment between the expectations. The maintenance team will implement this with the support of IT teams and anyone who works, OT to IT, including the IT team that can support with data transmission and so on, automation teams, Industry 4 teams that you see in these different facilities. It's crazy when you look at how industry's changed in the last 20 or 30 years. I say that as a 30-year-old, but still, for me, even in the last 10, it's quite ridiculous how digitalized everything's becoming and how much data is now available. Sometimes you have too much. And it's making sure that all the way from leadership down through to technicians, you've got a really solid understanding of how we're all going to work together, and just set yourselves up for success. And we do see a difference between customers who get that right and customers who perhaps in the early stages have struggled, and how that impacts the project. Yeah, I think just get those things really clear and you'll move twice as fast.
Yeah, I guess it's a balance as well, because there's certain things a vendor like Siemens can help with and support with as part of that process. But there has to be effort, let's say, from the customer side as well to do this right.
Absolutely. And it really is a great example of the more you put in, the more you get out.
Absolutely. So we've reached the promised lightning rounds. I haven't shared these with you before, Tom, so it's going to be a little bit of a surprise. But again, very short, succinct answer, well, even one word answers in some cases. So let's go for it. The first one is pilot or scale first. What's the smarter instinct?
Pilot. I would make sure you get that right in the first instance, and from there you can scale it afterwards.
Bigger risk in predictive maintenance, bad data or slow decisions?
I would say bad data. Really, that's fundamental. I think if you get data right in the first place, even if you don't have much, you can still do a lot more with good data. So bad data.
Excellent. And finally, so if you could fix just one thing on day one, what would move the needle fastest? I know we're sort of a bit more open that one, but yeah, what springs to mind?
First thing to get done, I would say cultural alignment with the team. Make sure everybody understands the objective and what are we trying to solve and achieve with a tool like Senseye.
Fantastic. There we go. But that's all we've got time for today. So I'd like to thank you, Tom, for joining us again, and you'll no doubt be recording again with us in the future.
Yeah, it's been a pleasure. Thanks for having me again. And obviously, everyone, thanks for listening. And if anyone's got any further questions, hopefully my contact details will be at the end of this.
It will. We'll add Tom's LinkedIn details to the show notes. But yes, thank you, everyone out there, for listening wherever you are. And we'll see you on the next episode. Thank you very much.
Please like and subscribe on all major podcast channels, and find out more about Senseye Predictive Maintenance at Siemens.com.